So in this video, we're going to talk about radical equation. So what is radical equation? First, we are going to define radical equation. When we say radical equation, it is an equation that contains a variable in the radicand. So these are the examples of radical equation. First, the cube root of x is equal to 2 square root of x plus 1 is equal to 4. Square root of x equals the square root of 2x plus 1. So these are the examples of the radical equation. So to solve square root equations, we are going to apply the squaring property of equality, or the SPE stands for the squaring property of equality. So how you are going to apply that? So the squaring property of equality. Okay, if two expressions are equal, then their squares are also equal. So in symbol, if let's say we have A is equal to B, so using squaring property, we are going to square both sides. So we have A squared equals B squared. So to illustrate and apply that in radical equation, consider that we have square root of x is equal to 3. So to solve this equation, square both sides of the equation. So get the square of both sides. Then, using the squaring property of equality, cancel the radical and the squared, and copy the radicand, which is x, equals, or copy the variable x, which is equal to the square root of 3. Of course, we have 9. Next, so the same concept, try to solve this. Square root of x minus 9 equals 4. Okay, again, using the squaring property of equality, so square both sides, cancel the radical, and copy the radicand. So x minus 9 equals the square root, or the square root of 4 is 16. Next, after that, we need to transfer this on the other side. So how? Using addition property of equality. So x minus 9 plus 9 equals 16 plus 9. So cancel this one. X equals 16 plus 9. So we have 25. And remember that the squaring property can be extended to any positive integer n. Like for example, if we have a is equal to b, then we have a raised to n equals b raised to n. So use this concept with the fact that, okay, so the nth root of a equals raised to n, so cancel that one, is a. Okay, let's say and try to solve this. How about if we have cube root of x equals 4? So to solve this equation, raise both sides to 3, because the index of our radical is 3. So we are going to raise both sides by 3. So cancel this one. X equals, so the cube of 4 is, or 4 cube. So our x equals 64. So in general, to solve a radical equation is to raise both sides of the equation in the nth root to the nth power. So we have a steps in solving radical equations in the nth root. So first step, isolate the radicals. Second step, raise both sides to the nth power. Third step, solve the indicated variable. And last step is check the answers. So to illustrate, let's try this one. What if we have cube root of x plus 1 minus 2 equals 0? So using those four steps, first isolate the constant or the radicals. So the cube root of x plus 1 equals 2. So this is our step 1. Next, after you isolate the radical or raise both sides to the nth power, okay, since our index is 3, therefore we raise both sides by 3. Okay, cancel this one. So we have x plus 1 equals 2 cubed. Okay, so x plus 1 equals 8. Next, third step. Okay, so third step is solve the indicated variable. So we need to solve the value of our x. Okay, so x plus 1 minus 1 equals 8 minus 1. So our x equals 7. Next, I'll try to check using the step 4. So check how you're going to check that. So cube root of x. Let's say that our x is 7. So cube root of 7 plus 1 equals 2. Let's try to check if that is true. Okay, so cube root of 7 plus 1 is 8 equals 2. So the cube root of 8 is, of course, 2 is equal to 2. Therefore, the value of our x is correct. Next, so some solutions do not satisfy the given radical equations. So these are called extraneous solution. Okay, how we are going to solve rational equations with extraneous solution. Okay, let's consider that square root of 4x plus 5 equals x. Okay, first isolate the radical. Okay, then after that square both sides. So cancel that one. So 4x plus 5 equals x squared, because that is the square of our x. Next, after that, simplify. So we have x squared minus 4x minus 5 is equal to 0. Next, after that, we are going to solve the value of x first through factoring. Okay, we are going to factor that. So what's the factor of x squared? We have x. Next, the factor of negative 5. Since in the middle part, it's negative, therefore, we put the negative on the large number. So the factor is 5 is only 1 and itself. So negative 5 then plus 1, because it's negative. And remember that negative times positive is negative, equals 0. And solve for the value of x. Equate both sides by 0. So x minus 5 equals 0 and x is equal to 5. And x plus 1 equals 0. So x equals negative 1. So check. Try to check that solution. Okay. So let's try to check that. First, again, our x is 5 and our x is negative 1. Okay, let's try to use this. So the square root of 4x plus 5 equals 5. Okay, because that's the value of our x. Next is 4 times, the square root of 4 times 5 plus 5 equals 5. Next, the square root of 4 times 5 is 20 plus 5 equals 5. So the square root of 20 plus 5 is 25 equals 5. So the square root of 25 is 5 equals 5. Okay, therefore it is correct. How about this one? Okay, so the square root of 4x plus 5 equals x. So let's say our x is negative 1. So the square root of 4 times negative 1 plus 5 equals negative 1. Next, square root of, or simplify, negative 4, or negative 1 times 4 is negative 4 plus 5 equals negative 1. Next, so negative 4 plus 5, we have square root of 1 equals negative 1. So the square root of 1 is not equal to negative 1. So after checking, we see, or we can conclude that negative 1 is an extraneous solution. This leaves that negative, or x is equal to 5 as the only solution. It means the x equals to negative 1 is not the solution. Only x is equal to negative 5. Okay? So that's how to solve radical equations using the squaring property and, of course, the extraneous solutions. So do not forget to like, share, comment, and of course subscribe on my YouTube channel for more videos about mathematics.